Hi, Mr. Unkert here. In this video, I'm going to review the Khan Academy assignment, Explicit Formulas for Geometric Sequences. So I have a geometric sequence here that starts with 12, then goes to 24, then 48, then 96, and so on. So we want to write an explicit formula for this geometric sequence. So we're going to start with the first number, 12. Then we have to raise that, or we have to multiply that by the number that we're multiplying the first number by to get to the second number. So let's just take our calculator and figure out what that number is. So I'm going to divide the second number by the first number. 24 divided by 12, that will equal 2. So I'm multiplying 12 times 2, but I'm multiplying that to the n minus 1 power. And I'll talk about, I have to do it like that, n minus 1 power. Talk about why that is. Okay, so n is the number of the term. So for the first term, n is 1. If I have 1 minus 1, I get 0. That would be 2 to the 0 power, and we know that anything to the 0 power, so 2 to the 0 power, anything to the 0 power is 1. Excluding any controversy about 0 to the 0 power. But, to get to the next number, though, we're going to multiply by 2 once. Okay, so to get to the second term, we're going to multiply by 2 to the first power. 2 once, right? To get to the third number from this first number, we're going to multiply by 2 twice, or 2 to the second power. So if you start to notice, every time we go up a term, we multiply by 2, one less than the number of the term. So to get to the fourth term, I'm going to multiply 12 by 2 to the third power. That's where that n minus 1 comes up from. And it's going to be that way for every formula, okay? So that would be 12 times 8, which would give me 96. Okay. That's why we're going to have the n minus 1 all the time. Okay, we're going to check. Look at that, energy points. It's going to be a good day, okay? Let's move on and try another question. Okay, so now we had the question where we had to come up with the explicit formula with the n minus 1. You'll also see sometimes they write it with just n, but then you have to manipulate it a little bit. And the way we're going to test this is we're going to test each formula with the first term and maybe the second term if the first term works. Okay, so in the first term, n equals 1. So let's do 1 times 8 to the first power. Well, 1 times 8 to the first power is 8. And I'm going to get my red because 8 does not equal 1. This is no good. Nice try, Bernardo. We're just going to cross you off here. Okay, Ogeki, I think I'm saying that right, said the formula is, the nth term is 8 times 1 to the n power. Okay, let's try that one out. So 8, for the first term, we're going to do 1 to the first power because n is going to be 1. So 8 times 1 is going to be 8. Notice the first term is not 8. So Ogeki, nice try, but no. So we're going to go down here and see that neither Bernardo nor Ogeki were correct. Okay. More energy points. It's a good day. Let's move on to the next one. All right. We're going to find the explicit formula this time. So we're going to start with the first term, negative 25. And we can use a calculator if we want, if you really needed to. But what do you have to multiply negative 25 to get negative 50? We're going to multiply it by 2. You're going to double it, right? And like I said, we're going to follow that format where we raise it to the n minus 1 power. because you're multiplying it to one less times than the term you're looking for. So I only multiplied the first term by 2 once to get the second term. I only multiplied the first term by 2 twice to get the third term. And I only multiplied the first term by 2 3 times to get the fourth term. So that's where that n minus 1 comes up. We're going to check our work, hoping for energy points, and we got them. It's a good day. And we'll go to the last one. Okay, now we're finding an explicit formula for the geometric sequence 120, 60, 30, 15. So you notice we're cutting our number in half each time, or we're multiplying by 0.5. So we're going to start with our first number. We multiply by 0.5, and I'm going to raise that to the n minus 1 power because we are multiplying by 0.5, one less than the term we're looking for. So for the second term, we're only multiplying by 0.5 once. For the third time, we're only multiplying by 0.5 twice. And for the fourth term, we're only multiplying by 0.5 3 times. And it would just keep going like that. Okay, check our work. Look at that. Perfect score. And that's basically it. And the great thing about these explicit formulas is that it allows you to find any term in the sequence rather easily, and it has an advantage over cursive formulas in that regard. So, explicit formulas will allow you to find like the 100th term, the 1000th term, etc. Although the 100th term, even the 100th term can be quite a large number for geometric sequences, or if you're multiplying by less than 1, quite a small number. But that's basically it for this Khan assignment. That's how you do it. And if you have any questions, leave comments in the comments below. Otherwise, thank you for watching and have a great day.